Okay, so now we'll move on to the classification of infectious diseases. And this section is basically just going to be a bunch of vocabulary words. So let's just get started. All right, so here are some terms that describe the occurrence of infections in a population. Sporadic refers to diseases that occur at random with just a few flare-ups here and there. So you only observe this disease occasionally. Examples would be tetanus. It's not like tetanus, again, it's not, remember, tetanus is a non-communicable disease. It doesn't spread through a population. You just get a case here, a case there. Rabies is another example. We don't tend to have outbreaks of rabies. Usually it's just a sporadic case here and there. And same thing with plague. Endemic. Actually, and you know what? I'm going to take plague back. In some places, plague is sporadic. But plague in New Mexico is actually a good example of an endemic disease. So endemic diseases are always present, but only at low smoldering levels. So for us in New Mexico, a good example would be plague. There's not a lot of cases, but it's always kind of there. There's always a risk of transmission to be aware of. So you're aware of it. You don't worry about it all the time, but you're aware that it's there, and you know, so, and you hear about cases once in a while. Epidemic. So an epidemic is a higher rate of cases of infections than would be expected with an endemic disease, like influenza every year, late fall to early spring. Epidemics are relatively controlled compared to pandemics. So a pandemic is a worldwide epidemic. So they're widespread, they've been passed around the world. Examples would be the Spanish flu, which we talked about early in the term, HIV, also novel coronavirus, COVID-19. So these are higher rates of infection than with an epidemic. They move worldwide. So epidemics occur because of a change in host ecology, or a change in the human ecology. Something about the environment, about how the hosts are interacting, about how host health has changed to promote the spread. So the humans have started behaving in a different way. The humans have started interacting in a different way. Human health has changed. Those are the kinds of things that can change, that can move a pathogen from endemic status to epidemic status. Or maybe the disease experiences some mutation that allows it to overwhelm the host's immune system and spread more rapidly than it did. So it can either be a change in how the host is behaving or host health of the population as a whole, right? It's not one individual, it's the whole population, right? When we're talking about moving a pathogen from an endemic status to epidemic status, either something about the human population has changed or the disease mutates so that the human population no longer knows how to handle it. And these days, it's very easy for an epidemic to become a pandemic because of globalized travel. So it's, you know, we don't really have just epidemics anymore, right? The flu, you have an epidemic one place, it becomes a pandemic because it moves to another place. So here's some terms that describe types of infections. A primary infection basically, it's the first infection, the infection that causes the initial infection, or the pathogen that causes the initial infection. So a primary infection can knock back your defenses, right? And then a secondary infection is a new infection that occurs because of the body's weakened immune system. So you got sick with the flu, and then you developed pneumonia. The virus, the flu, is not giving you pneumonia. The virus of the flu, it overwhelmed your immune system. Your immune system is now not functioning how it should. And so you became vulnerable to other pathogens that could give you pneumonia. Okay, so the pneumonia is the secondary infection, the flu is the primary infection. So the primary infection is caused by a pathogen that can make you sick even when you're healthy. Secondary infection is caused by a pathogen that's maybe a little bit more opportunistic. It only was able to infect you because your immune system was already fighting something else. Your immune system was weakened. That's one definition of a secondary infection. There's another definition of secondary infection. So secondary infection can also refer to the spread of a primary infection to another body site. So for example, You can have a skin infection, or a UTI, which left untreated can become pneumonia. So if you have a UTI and you leave it and you don't treat it and it gets really, really bad, the bacteria causing the UTI can then enter the bloodstream and move to another part of your body, like your lungs. So you can actually get pneumonia from your UTI. Or same thing with a skin infection. So the primary infection was the UTI, the pneumonia was the secondary infection. It's actually the same bacteria, but it's moved to a second location in the body because the infection got bad enough. So secondary infection can be a second pathogen that's only been able to move in because a first pathogen weakened your body, or it can be the first pathogen the infection progressed so much that it moved through your body to a second body site. Third vocabulary word on this list is subclinical, a subclinical infection. That is an infection that shows no symptoms. So sometimes a person can be infected with a pathogen, but not come down with a disease. So the pathogen is the microbe, the disease is the symptoms. So some people can have the pathogen living in their body, but they have no outward sign of disease. They don't know that they have the pathogen, they're not sick. So an interesting example would be Mary Malone, also known as Typhoid Mary. You should Wikipedia her. It's a really interesting story. Mary Malone was found to be an asymptomatic carrier of typhoid, and she was a cook. And though she displayed no symptoms, she had typhoid microbes in her system. And as a cook, she infected 51 people, 3 of whom died. Now, health officials deduced that it was her because sometimes she worked in a public setting for a lot of people, like at a restaurant. Sometimes she worked in rich people's homes. But everywhere she worked, people were coming down with typhoid. So health officials determined that it was her. And at the time, nobody understood that you could have a subclinical infection. People didn't understand asymptomatic carriers. They didn't realize that you could have a pathogen and not be sick. But they figured it out because of her. And health officials forced her to spend 30 years in isolation. She ran from them for a very long time because who wants to live in quarantine for 30 years for their whole lives, right? So it's actually kind of a sad story, and it's really interesting to read about. There's a whole Wikipedia article on her. All right, terms that describe types of infections. So we have local infections. These are infections that are contained to a particular area. You might have an abscess in your skin. That's a local infection, or a boil on your skin. It's localized, right? It's one part of your body. Even pneumonia, that's a local infection because it's just your respiratory tract. It's not your whole body, right? Or a UTI, localized. It's just in your urinary tract. And probably just in the urethra, right? Probably not even in the whole urinary tract. Probably not in the kidneys. But even if you have a really advanced UTI and it's in the kidneys, if it's just in the urinary tract, it's still considered a local infection. A systemic infection is an infection where the pathogens have entered the bloodstream and they're riding the bloodstream to other body regions. When you have a systemic infection, this causes secondary infections, right? So we talked about secondary infections on the last slide, how the primary infection can move to another part of the body while they're moving through the bloodstream. So that's when you have a systemic infection, it leads to a secondary spread. So for example, the UTI to the lungs. Septicemia is progressed systemic infection. So when you have a systemic infection, the pathogen is just riding the bloodstream. If you're septic, it means the pathogen is actively replicating in your bloodstream. So for example, you could have bacteremia. That means that bacteria are actively replicating in the bloodstream. Viremia, viruses are actively replicating in the bloodstream. Toxemia is when you have toxins in the bloodstream. So you may have bacteria as well, but you might not. You might just have the toxin itself. So you could have toxemia from a rattlesnake bite or from botulism. So we talked about botulism in the previous lecture. So botulism, you don't get infected by the bacteria. You don't get infected by Clostridium botulinum. What happens is you eat food that the Clostridium botulinum has been living in. It's been excreting its toxins into the food. When you eat those toxins, you become sick. So that would be an example of toxemia. So let's talk a little bit about herd immunity. Herd immunity is provided by people who've gotten the disease and survived, or people who've become immune through vaccination. So the rate at which a disease or an epidemic spreads and the number of people involved are determined in part by the immunity of the population. This is known as herd immunity. So vaccinations can provide long-lasting and sometimes lifelong protection to an individual against a certain disease. It's the same thing as getting sick, except you also become immune to a disease when you get sick, but vaccines just allow you to skip the whole getting sick part. And that can be useful for pathogens where you might not survive them. So for the common cold, that's fine. You can just get sick and become immune that way. But for something like measles, where there's a high risk of mortality, it's useful to get a vaccine because then you can skip the getting sick part, you can skip the risk of dying from the disease. So people who are immune to an infectious disease will not be carriers, thereby reducing the occurrence of the disease. They can act as fire breaks against the spread of disease. So if you think about, everyone has a bubble of other humans, a bubble of their community around them, their friends, their family. If you yourself are not immune to a disease, you didn't get vaccinated, you couldn't get vaccinated, and you never had the disease before, but everyone surrounding you is immune, those immune people are protecting you from becoming sick. So if some individual comes into your state, your community, who is sick with a particular pathogen, but everyone you surround yourself with is immune, it's not likely for that pathogen to then be transmitted to you because it can't move through the immune individuals. So we can say, you can use the analogy of a fire break. So with a fire break, you have a forest, you cut down a whole bunch of trees in a row, and so there's no trees in this one particular area. There's no way for the fire to spread across that fire break, right? And so immune individuals are sort of like a fire break to the spread of a disease. So it's difficult to talk about herd immunity without understanding a little bit about immunity itself, which we're getting into next chapter, chapter 15. But I'll just give you a brief introduction. So when you get sick with a pathogen, when you meet a pathogen for the first time, you get sick because your body's never encountered that pathogen before. Your immune system doesn't know it. So the pathogen grows and grows and grows, divides in your body, making new generations, spreading through your body. While it's doing that, and while you're getting sick, your immune system is in the process of building chemical memory against that disease. It just takes a little time. It's difficult. Your immune system has to go through this process of recognizing the pathogen, then generating a chemical memory against it, and it just takes some time. So at first, the first reason you get sick is because your body doesn't recognize the pathogen. Then you continue to be sick because your body is in the process of generating that chemical memory against it. Once it's recognized that there's a pathogen, it has to generate that chemical memory against it. But once that memory is built, provided the disease doesn't mutate or change dramatically in some way, your body will quickly quickly identify that pathogen upon a second meeting. And that allows for a very, very speedy response. So the second time you encounter a pathogen, you have this chemical memory. You actually have an entire army of white blood cells devoted just to that one pathogen. So the second time that pathogen enters your body, you might not even notice it because your immune system will nip the infection in the bud, will attack it, will get rid of the infection before it even has time to give you any symptoms. And that's what we call immunity. It's not that the pathogen never enters you again. It's not that you never encounter the pathogen again. It's that even if the pathogen gets into your body, your immune system destroys it before it has time to make you sick. So here's a link, and you can find it in the course website, to a really, really great video explaining herd immunity. It's a requirement. You have to watch this before you complete the quiz and the homework assignments.